Okay. Hello, everyone. My name is Yeting Wu. Today I want to introduce a very famous mathematician named Srinivasa Ramanujan. His picture. Okay. Srinivasa Ramanujan was an Indian mathematician, often regarded as one of the greatest mathematicians of all time. Though he had almost no formal training in pure mathematics, he made substantial contributions to mathematical analysis, number theory, infinity series, and continued fractions, including solutions to mathematical problems then considered unsolvable. He had little access to formal education and was largely self-taught. From a young age, he developed a deep interest in mathematics and focused almost exclusively on it, neglecting other subjects. When he was 16 years old, he obtained a copy of George Shobridge Carr's synopsis of elementary results in pure and applied mathematics. This collection of thousands of theorems made it present with only the briefest of proofs and with no material newer than 1860, lost his genius. Having verified the results in Carr's book, Ramanujan went beyond it, developing his own theorems and ideas. In 1903, he secured a scholarship to the University of Madras, but lost it the following year because he neglected all other studies in pursuit of mathematics. Let's see picture. Let's see the struggles and challenges. Ramanujan continued his work without employment and living in the poorest of conditions. After, after marrying in 1909, he began a search for permanent employment that culminated in an interview with the Secretary of the Indian Mathematical Society, Ramchandra Rao, impressed by Ramanujan's mathematical prowess. Rao supported his research for a time, but Ramanujan, unwilling to exist on charity, obtained a critical post with the Madras Port Trust. Its contributions to mathematics. When Hardy first received Ramanujan's letter, he was incredulous of Ramanujan's unorthodox methods and lack of form proofs. Upon reviewing the sermons, however, Hardy recognizes the path of Ramanujan's work and arranged a special scholarship at the University of Madras and a grant from Trinity College, Cambridge. In 1914, Ramanujan moved to England, where he worked alongside Hardy. Despite the challenges posed by the cold climate and his delicate health, their cooperation proved fruitful, resulting in significant advances in areas such as modern forms and prime number theory. One of the more well-known stories of their partnership involves the number 1729, which is now known as the Hardy-Ramanujan number. When Ramanujan was admitted to a hospital because of ill health, Hardy visited him and mentioned that the taxi he arrived in was numbered 1729. Noting that he found the number unremarkable, Ramanujan immediately pointed out that 17 29 is actually quite special. It is the smallest number that can be expressed as the sum of two cubes in two different ways. 1729 equals 17 plus 123 equal 9. Its legacy and modern impact. In 1920, shortly before his death, Ramanujan wrote a letter to Hardy describing a series of new mathematical functions, which he called Mach modular forms, and outlined a theory about their behavior. These functions puzzled mathematicians for years. In 2012, researchers led by Emory University president findings at the University of Florida that confirmed Ramanujan's theories. Although noted that these Mach modular forms could potentially unlock insights into modern scientific phenomena, including black holes. Such discoveries underscored the enduring significance of Ramanujan's work. Ramanujan's life and contributions were brought to the screen in The Man Who Knew Infinity, 2015, starring Dev Patel as Ramanujan and Jeremy Irons as Hardy. Okay, that's Ramanujan's a very famous mathematics. Thank you.